I've got this thing that I do with tuning cars. Even though I look at all my electronics and data that I see, I always love to pull the spark plugs out after every 2-3 runs on the dyno and actually read the spark plug to see where the timing's at. To me, that's very, very important, because you just want to make sure what you're doing is 100% and the plugs don't lie.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're interviewing Mick Baghdadi from Micks Motorsport in Australia. Mick is someone that I've known for well over a decade now. We both share an interest in 4G63 Mitsubishi engines and specifically drag racing. Mick was drag racing an early generation Mitsubishi Evo 1-3 shaped car back when we were running Docile, our old shop Evo 3, which at the time held the world record for Mitsubishi Evo four-wheel drives with an 8.23 at 180 mile an hour on the quarter mile. In this interview, we dive deep into the world of drag racing and specifically all things 4G63. You're going to hear a lot of inside tech that you don't generally get to find out about. What makes these cars so fast? We talked to Mick in particular around the cast block versus the billet blocks, which are now so prevalent. Mick's current shop car, his red Evo 8, is the first Evo 8 in Australia to run into the 8s, basically in a full street legal trim. This thing weighs 1,500 kilograms and on its latest trip to the dyno punched out just under 1,500 horsepower at the wheel, so it is no joke. Mick also shares the love as well, because it's not just the 4G63 that he is really competent at building and tuning. He's also got his own shop S15, which is a 3/4 chassis car, which is fairly deep in the sixes, running an SR20 VE engine, so find out all about that as well. Heaps of great information in this, and I hope that you'll enjoy it as much as I did. Before we jump into that though, just a quick introduction for those who aren't aware of what High Performance Academy is. We are an online training school. We specialize in teaching people how to build performance engines, how to tune aftermarket and factory engine management systems, how to wire up your car, and we also cover driver education, race driver education that is, and car setup topics, as well as data logging. You can find out more about us at hpacademy.com/courses. Also today, given that we are talking a lot about engine building, a course that is really relevant to today's topic is our practical engine building course. This covers everything you need to know in order to build your own engine in your home workshop. And I know this is something that a lot of enthusiasts get put off about, thinking that it's simply beyond them. You might be surprised to find out that it's actually something that any enthusiast with a little bit of an eye for detail and a bit of patience can achieve, and you're not going to need to break the bank in terms of specialist tools in order to get the job done. That particular course also includes a simple 10-step process that you can apply irrespective of what engine you're building and what you're building that engine for. And again, relevant to today's topic, we do have a full worked example in that course that covers the build of an Evo 9 4G63. That's a 2.2 litre stroker engine that's designed to produce around about 800 horsepower, run to about 8,000 RPM, and that's going to be going into a street car that's going to be used for a little bit of competition. So perfect for those of you interested in learning a little more about the 4G63. For those who are new to High Performance Academy as well, you can use the coupon code podcast75, and that'll get you $75 off the purchase of your very first HPA course. And we'll put a link into this description for that course as well as that coupon code. All right, let's get into our interview now. All right, welcome to the podcast, Mick. Thanks for joining us today. And we've been following you for years because we've got a mutual love of 4G63s and drag racing. But for our listeners out there, could we maybe just get a quick sort of 30,000 foot view of how you got involved in motorsport tuning and engine building to start with?
Oh, it was probably back in 1988, 89. My brother's a mechanic, does performance cars and that. And after school, he used to pay me a little bit to hang out with him and watch him do what he did. And I pretty much fell in love with cars and, started tuning cars with him and just teaching me at a young age. I was only like 14, 15 years old, and I knew that's what I wanted to do for the rest of my life.
So you weren't raised, or you didn't train as a mechanic, you kind of just fell into that via your brother?
Yeah, that's right. Like, I was only still at school. I was only young. So once I started with him working on cars and that, obviously I got into TAFE and got my first job, and I tried to do it normal mechanic, couldn't do it, so I went straight into the performance game.
Okay.
From the word go.
For those outside of Australia, TAFE is a training college essentially?
Correct, yes.
So for trades?
Yeah.
Okay.
Learn the trade, and learned all the basics about engines and that.
So you kind of went around it a bit of a backward way. You sort of got involved via your brother, then went back and decided you wanted to become a mechanic as a trade, but then that didn't really work out for you?
Yeah, no, I still did the trade. You had to do it to get my license and that. But obviously when you go to TAFE, they don't teach you anything about performance. It's just all your basic mechanical, which is definitely the way to do it, because you need to know all your basics first before you start doing performance. So once we got our ticket, we started working, and to become a normal mechanic, I didn't want to do that. That's when I started doing performance from the word go.
And could you give us a sense of back then when you first started, what was the performance scene like? What sort of cars were you working on, and what was the level of modifications that you were sort of performing on them?
Back then there was pretty much no turbos at all. If you had a turbo, you just look and say, what does that do? We had no idea. Didn't even know what it was, to be honest with you. And most of the cars back then were all carbureted and normally aspirated. So yeah, it was pretty basic. We still did a lot of V8s, and I got into the performance game. My first car was actually a Holden Gemini, just normally aspirated. Started mucking around with that, tuning Webers on it and building engines and developing that. And we concentrated on the Gemini scene for a good solid, 5 to 10 years in between that. And we started to get it really going, running like 11 seconds down the quarter, normally aspirated.
Wow. Back
in 1996, 97. So it was very, very quick. That's when the turbo scenes really started to kick in, like in the 95, 96. That's when we started to muck around with all the turbo cars, get into it as well.
And just jumping back one step, I'm always interested, because I never trained or became a qualified mechanic, but I know these days a lot of our members will come through with no prior knowledge of mechanics at all and want to jump straight into tuning, which 100% you can do. I kind of was self-taught as a mechanic and then moved into the tuning. And I've always found that having that background understanding of the mechanical operation of the engine has helped me as a tuner. It's definitely not an essential element, but particularly when it comes to fault finding and diagnostics, we're still dealing with a mechanical system. So understanding how the ignition system, for example, works, or the valve train, that can help you quickly diagnose a mechanical issue that there's no way you're going to be able to fix from behind the laptop keyboard. How do you feel about that?
Yeah, no, you're right there, 100%. Mechanical knowledge on how everything works is actually very, very important, especially if you're a tuner. Like you said, you do need to know the ins and outs of an engine, how everything works. So if you do have a problem while tuning, you know what to look for, because it could be not a tune problem, it could be an engine problem, and you could be chasing the wrong problem. So understanding how everything works, valve train wise, just everything in general, it's very, very important.
Yeah.
Because without that knowledge, it's not going to be easy to tune a car correctly, that is. So
now, you mentioned sort of mid-90s was when you started to see the advent of turbo. So how did that come out? What sort of cars were you seeing those on, and how long did it take before you kind of worked out that this was the way forward in terms of going faster?
Well, to be honest with you, we used to go to the track, and we were proud of ourselves, what we were doing, running 11s in a normally aspirated Gemini, and there was a lot of turbo cars back then. all running like 12s, and they started to dip into the 11s, and we go, wow, look what we're doing compared to what they're doing. But like within 6 months to about a year, man, these turbo cars started running 10s and 9s, and we couldn't believe it.
Yeah.
So we said to ourselves, we're going to have to jump on board, start mucking around with this turbo stuff and see how good it is. And haven't looked back. It's been a big game changer ever since then. Like, it just gets more and more advanced every year. Just times are just going faster and faster. It just doesn't stop.
I mean, they say it's the replacement for displacement, and to a degree, you've got to agree with that. It definitely. The other thing, as you just sort of mentioned there, over the time I've been involved with performance cars, the turbo technology, I was lucky enough that basically that was all I knew right from the time I got involved. But particularly the improvements we've seen in turbo technology over the decades have just been massive, allowing us to make that much more power without sacrificing the response that we had back in, like you say, back in the 90s. How critical has that been for what you've been able to do with these cars?
Oh yeah, definitely. Like back in the days, to make power with a turbocharged car, we're all buying big turbos and to make the power, and very laggy. It's hard to get them on boost, and the technology just wasn't there, but it run the times in that, and you'd make the horsepower, but it was hard work. Where today's technology, the way they're making turbos and how things have gone, it's like, honestly, big difference, making it easier for us, to be honest. And yeah, man, like the turbos we're running these days are pretty much bigger than the engine that we've got, like 2-litre capacities or 2.2s with massive turbos, and they spin them as if they're nothing. So
yeah, I think it's important for those who are maybe growing up at the later end of the turbo era as well to understand that back at the start there, we didn't have access to off-the-shelf performance turbochargers like we do now, or certainly not the range, and a lot of people were working with secondhand truck turbos, basically whatever they could get, often with no specifications, and it was kind of a case of bolting it on and keeping your fingers crossed and hoping for the best.
Yeah, you're not wrong there. Like our first turbo we got, I think it was off of some truck, had a massive rehousing on it. Like it was that big. We go, wow, this thing's going to be good. And you look at the front cover, it was tiny with a little turbine wheel, like totally opposite to what we do today. And yeah, man, we put it on there. It took forever to come on, and it was bad. But, we had a turbine now. We were excited, and,
Yeah, well, thank goodness for technology and the fact it's marched on. Now, before we move into some of these cars that I want to talk to you about today, can you just give us a sense now, years on, what sort of size is Micks Motorsport? How many staff have you got, and what are you predominantly working on in terms of the cars you see through the doors these days?
Oh, look, our staff here, our shop's not really that big. It's, we've got a lot of work for the workers we got. There's only 3 to 4 employees at the moment. We do have a subby that comes in when we need him to keep us going. But most of our work now is all like Evos and Nissan S15s, S40 on the SR20 platform. We do tune anything when it comes to tuning, like whether it's a V8, 6-cylinder, 4-cylinder. We do some rotaries here and there.
Yep.
But yeah, we mainly concentrate on the Evo scene and the Nissan SR20. They're our favourites.
And I think there's something to be said, and most performance workshops do end up kind of becoming known for a particular platform, or in your case a couple of particular platforms, and that's kind of a natural progression. But just what you mentioned there, I think, is important to sort of just reiterate, is that you tune anything that comes in the door. One of the questions we quite often get asked is, well, how do I tune XYZ brand of engine if I haven't ever seen that engine before? And my point to that is, if you understand the principles behind tuning, you can apply those principles irrespective of what that engine is. You don't need to have seen 10 of that particular engine on the dyno in order to get good results. Do you agree with that?
No, you're definitely right there. Like, tuning is tuning. If you apply all the principles when it comes to timing, mixtures and that, don't get me wrong, every engine does have, it might have a weak point.
Yep.
Where some engines don't like to run a certain air-fuel ratio where you run on other engines that can live. That's something, hopefully we don't have to work out the hard way, but you can definitely see the difference, like when you're tuning the car, where it's happy, where it's not happy. When it comes to detonation, every engine's the same. You got to make sure the timing's in the right place at the right time. And with the technology you got these days with knock control, and depending on what ECU you're running, and that, it also helps you along the line if you're tuning something that you're not familiar with. You know what I mean? So it's you need to know how to have the experience as well. But we're not scared to tune anything. We'll do whatever we've got to do. If it's been built, it's a bonus, because you do get your engines here and there where the rods are very weak. They can't, accept any power. Even though the tune could be perfect, it could still snap a rod or hurt the engine, and it's not your fault, but
There's an important aspect to maybe dive into as well, because we always hear these stories about tuners that have blown up engines, and that kind of goes hand in hand with the other comment we quite regularly hear, is that you have to blow up a bunch of engines in order to learn how to tune, which I completely disagree with. I think if you're doing your job properly, you shouldn't be running the engine into detonation or knock, and you should be able to tune it with safe air-fuel ratios. But as you've just mentioned there, that's not always going to guarantee that the engine's going to hold together. So, understanding perhaps the known weaknesses of a particular engine brand that you're dealing with, so that you've got an understanding of where the limits lie, and maybe what you might need to apply in order to keep that engine alive. That's a safe or a sensible approach for a tuner.
Oh, definitely. Like, you get some engines that are very weak. Like everyone knows, a 4G93, for argument's sake, that you can't push them too far. The rods come out pretty quick. Same thing with early model Evos, like 4, 5 and 6. We've seen them blow up. The car's never been tuned. They're snapping conrods. If they go to 25 pound, like the hose leaks or the wastegate gets stuck, they blow up straight away. So you could be one of the best tuners. If that rod's ready to break on an early model Evo, it could happen to you. You know what I mean? Where we've had experience with Evo 8 and Evo 9 engines, we've pushed them to 400 kilowatts, completely stock standard, and they've been going for 5, 6 years, not a problem.
Yeah, I mean, I think there are major changes in terms of the engine strength across the generations of, particularly, as you said there, the Evo engines. But I mean, back in the day, we were also involved with a customer who wanted to run a stock block Evo 9, I think it was, world record, which, as its name implies, completely stock long motor. And I think we ended up around the 500 kilowatt at the wheel mark, but at that point we were very careful as well with detuning both the boost and the ignition timing around peak torque to give the rods half a chance of staying together.
Yeah, definitely. That's very important. That's the most critical part in the engine, where it makes peak power. You got to be careful in that area, from lifting heads and putting a lot of stress on all the components.
Yeah.
So that's where most of your problems are. That's why when you go into a stroker engine, your cylinder pressures become greater. So that's very, very important in tuning, timing-wise, and that's when you start lifting heads, and that's where it plays a big role to know what you're doing and have the experience in that field, from not damaging engines. You know?
Absolutely. All right, so let's move on. And the first car that I really wanted to deal with here is your old early generation Mitsubishi Evo, because I was sort of drag racing our Evo shop car around about the same time. And in fact, I think we took it to Australia and ended up running at the same event, which was Jamboree at one point in Brisbane. How did you sort of focus on that platform, the Evo 4G63 platform? Why did you sort of go from the Gemini, which obviously you mentioned was your one of your favourites at that point, to swapping to the Evo?
To be honest, that's your fault. You made me do that. I've still got the pictures of your car, trying to copy it, like do the front, copy everything I can. I tried my best, but your car actually inspired me to do the early model Evo. I was into them, but not to that extreme. And when I seen your car and all the other boys from New Zealand, because I think he's brought down that year 2 of them. There was another black one.
Correct, yeah. Zohab's car.
And I never forget that day. It was like yesterday, to be honest with you. It was I wanted to do what you guys were doing, and that's when I started building my early model Lancer. And it was probably the best move we've made. We started building that car up, back then we didn't run as much power. We only had like 750 at all wheels, and it ran back then, I think it was 8.7 over 165 mile an hour, and it was only like on 32 pounds. Compared to today, it's nothing at all. And like, we didn't have the technology back then, and it was only on radials too, so it was only the beginning of us learning how to set cars up and do what we had to do.
Now, for those listening and thinking maybe 8.7 doesn't really sound that impressive, it's important to mention this is quite a long time ago now. We're talking between 10 and 15 years at a guess. Does that sound about right?
Yeah, it was probably back in 2004, 2005, okay. Correct.
Yeah. All right, so can you give us a bit of a rundown? I mean, obviously 750 horsepower at the wheels, as you mentioned, these days, it's definitely, we've got street cars probably making that much, if not more. So it's definitely not a challenge these days, but this was an earlier time. We didn't have access to the turbos, which we've already talked about. So can you give us a rundown on what went into the engine combination to hold together at that sort of power level?
Yeah, back then I only used to use the 6-bolt engines because we had plenty of them around here that were cheap enough to, if you blow them up, cheap enough to go and get them from the wreckers. It was very expensive back then to buy like an Evo 123 motor 7-bolt, which was definitely a better option, but we couldn't get them at the time. So we pretty much got a Hyundai Sonata block, Tour Deck, 64 block. We put a crank in it, 100. That we tried a couple of different combos, but I ended up with 106 mil stroke, like a BC crank. And we used to mix and match the parts. We'll put Manly 6.1 rods in it and a custom CP piston. So we've set the bottom end up pretty solid. Didn't rev too high. It was only making best power till about 8.5. You wouldn't want to rev it any harder than that. But we actually set that car up with big tyres. We set up the ratios to run like close to 170 mile an hour. And we've done the head on it. Had the early model VR4 head on it. Made our own custom platinum chambers, twin injectors, methanol, turbo.
All right, there's a bunch of stuff there to unpack. So let's just come back, because one of the arguments, I guess, or conversations that I heard a lot on the enthusiast forums back around that time, where there was that switch between the US domestic market DSM 6-bolt, Japanese version was the Galant VR4, or you said Sonata, not one that I'm familiar with. So that was the 6-bolt crank, and then the Evo 1 onwards that went to the 7-bolt crank, where a lot of the internal components, particularly the conrods, physically looked a lot smaller. And I know at that time there was a bit of a trend to swapping back to the 6-bolt block for some supposed strength advantage. Personally, I never went that way. We only ever ran the 7-bolt blocks, 7-bolt cranks, and I really never had any issues. What's your take? Is there a strength advantage one way or the other? You just did the 6-bolt because it was what it was available to you cheaply? Yeah,
well, we did it then because it was definitely cheap, but my preference would be definitely to go to an Evo 123 engine. The early model blocks didn't have a girdle. They were single cap.
Yeah.
So the Evo had the big advantage of having a full complete girdle, which is much better to hold the crank in place, especially when you go to a stroker crank. And there was a lot of development on the early model. We had to put billet caps in it and make girdles for it. So there was a lot of work involved, where if you could get the Evo engine, you're going to save a lot of money in the long run. And to be honest with you, they're more reliable, and it had the better crank in it, the 7-bolt, and you could buy more parts for it. Had the bigger pins to start off with, and without doing too much mods on the early 6-bolt engine.
So you're talking there the wrist pin, the 22 versus the 21 millimeter
right.
wrist pin.
Yeah.
So I mean, obviously
Correct.
A lot of these modifications could be made in the aftermarket, but it just depends where you were on the sort of starting point. And talking about that girdle or cradle, that's what supports the crank and bolts it into the block. On the 7-bolt Evo 1 onwards, that was a complete cradle that supported all 5 main bearing caps in one cast unit, and the Galant 6-bolt VR4 from memory had a single center main, and then the front and 1 and 2 caps and the rear 4 and 5 were together. Was that correct?
Correct. Yeah. That was on the VR4, but the Hyundai Sonata block we used to use wasn't like that. It was just all single caps. So the only advantage of using that block, obviously, was a tall deck.
Yep.
So it had the 6 mil longer deck, so you can actually run the stroker crank and run the longer rod to make up for a little, like, slow the piston speed down a little bit.
So you're sort of claiming back some of that deficit to the rod to stroke ratio with going with the longer stroke crankshaft.
Yes, correct.
Now, was that the same as the conventional 4G64 block, though, where we stepped from the 85mm bore size on the 63 to the 86.5mm on the 64?
Yeah, that's correct. Exactly the same.
Okay. So one of the things I think I ran one stroker engine with a 64 block. And one of the things which may or may not have proven to be a real issue, maybe it was just in my head, was when you're starting with the 86.5mm bore, generally engine building 101, if you're dealing with an old block that's a bit of an unknown quantity, you're probably going to go to a first oversize, which is 20 thou or half a mil larger in the bore. So straight away you're at 87 millimeters versus if you're dealing with a good 63 block, your first oversize is 85.5 millimeters. Now, that might not sound much, but what it does do, you haven't got a lot of material in the 63 blocks between the adjacent bores. And I was always sort of a little bit nervous when you went out to 87 millimeters, that's starting to get kind of scary small for me. Is it an issue, or is that just in my mind?
No, look, it can become an issue, but the 64 blocks we used to use, they're Siamese bore, so there was no water running in between.
Yeah.
On the Hyundai block, so they still had the strength, and like being a drag car, it really didn't bother us because it was always full of concrete. It never had any water in it at all. But as a street car, definitely it still worked. Being 87 mil, we've actually bored them out to 88 mil and never had a problem.
Okay.
But in today's boost pressures that we're running are definitely not recommended. If you're going to build an engine to run 30, 35 pound, yeah, you can definitely get away with it. But if you're going to put 60, 70 pound in it, the smaller the bore, the better. So you got strength in your bores. That's my recommendations anyway. So
okay. There's a couple of other things there. You mentioned you'd gone to, was it 106 millimeter stroke crankshaft?
Yes, correct.
So typically we start with the factory 63s and 88 millimeter stroke, and then the 64 2.4 litre block that ran a 100 mil stroke. So what was your final capacity there?
It was almost 2.6 litre.
Wow. Okay, it's a big four cylinder.
It was like a little truck motor.
And that's why you're saying you're sort of balancing the capacity versus the ability to rev. You said, I think, 8,500, whereas we're spinning our 2 litre out to 10,500, 11,000.
Yeah, 8.5 grand. It was pretty much all over, man. There's no way it'd do more damage to the engine than good if you revved it any harder than 8.3 to 8.5. That was it.
Yeah. Now, another thing I picked up on there, you said you used the 6-bolt cylinder head as well. The cylinder head from the 6-bolt block. And I'm guessing here, I've only ever seen the Galant VR4 head, but that's the same head you're talking about there?
Yeah, it was a VR4 head, completely the same.
I mean, if anyone's seen those side by side with the later Evo 1 onwards, the initial glance, you look at the intake ports and they are absolutely massive. So I know a lot of people sort of looked at that and thought, well, obviously they're going to outflow the later 7-bolt Evo 1 onwards cylinder heads. Is there any truth to that, or is this a case where bigger isn't always better?
Look, bigger's not always better. The later model Evo heads are definitely working with the port being the size that it is. From factory, the big port, they used to run the tumbler valves inside of them because they were that big. So there's no power down low. The port's absolutely too big. And again, if you're going to run in the 30, 40 pound boost, the port is pretty big. You are going to lose a lot of response, and like for a street car, it's definitely the ports are massive. But at the end of the day, they still work perfect. On the street car, we've never had a problem. We've had early model Lancers making 800 horsepower at the wheels, street cars, and they don't lag on power or anything like that down low. So, but it's very surprising that the port difference and the later model ones can still flow the same. Yeah. So
I think definitely head porting is something that I do not profess to be an expert on. That's an area where I think there's art and science sort of kind of go hand in hand with that. But I mean, from what I do understand and those I talk to, it's very much a case of bigger is not always the way, and it's about improving the flow while retaining air velocity, where just hocking out a port as big as you can go, it might get the flow numbers, but you sacrifice that air velocity, which then in turn can hamper particularly your low RPM performance. So there's a lot to understand there before you just hang on the end of a die grinder and see how big you can make it.
That's 100%. In some cases, you look at the late model heads on not turbo cars, like even on the V8 stuff, man, the ports are getting smaller and smaller. Height plays a big role. They're raising the ports. Exhaust, they've raised it heaps, changed angles and that, and the heads just flow so much more power. Compared to the old days, the ports were massive. Like you say, well, you can nearly put your hand in there. And even those heads, they're filling up half of the port and they're flowing more.
Yeah.
Like for argument's sake, it's off the case, like we're talking about Ford V8 Clevelands. Like we used to fill up the port halfway, put tongues in them, and they flow more and they make more power, and the port's half the size. So
yeah,
big isn't always better, that's for sure.
Right, let's come back to the rest of that engine combination. Now, you've already mentioned you're not really making huge power levels or running a huge amount of boost. I think you mentioned, was it 32, 35 PSI?
Yeah, 32 pounds, yeah.
So at that point, where are you sort of seeing the weaknesses or limitations on that engine, or had you not really reached them at that sort of power level?
No, it was very reliable at that power level. We never really had any problems at all. We were pretty much still trying to dial the car in and get things working properly, like the launch control. For the power that it was making, we were very, very happy with the ETs that it ran back then. And then we stayed like that. Like we didn't continue with the car for a while because we're trying to concentrate on the business, running it and stuff like that. And then I don't know what got into me. We got stuck into the SR20 stuff. So
it's a bit of a change. Normally the Mitsubishi guys and girls sort of stick to their corner.
To be honest with you, I love both. I can't even say I love the SR20 more than the Mitsubishi. If I do that, I'd be lying. I love them pretty much the same. So it's very hard for me.
All right. Well, you've got a long and successful history with the SR20, and I do want to talk about that. But before we sort of finish off on the 4G63, I'll stick to what I know for a little bit longer.
Yeah.
In terms of getting that car to go down the strip, power is actually not the only thing we need to worry about. It's really the whole package, and particularly one of the things I know that I struggled with was getting the car to 60 foot well. You've got a four-wheel drivetrain with four relatively big sticky tyres, particularly the quality of the tracks you guys had access to in Australia. They're incredibly sticky. So you got to a situation where it was very easy to break drivetrain components. And then even if you didn't break something, you were balancing that sort of walking that tightrope between lighting up and wheel spinning when you drop the clutch or bogging in. What can you tell us about your approach to that? How did you get around that? And what were you 60 footing in?
Okay, originally when we first got the Lancer going, we got the PPG dog box and it had a lock-up like for they run a viscous from front to rear. So we put the modification they make to lock the shaft so it had even power front to rear. We also had a full spool in the front diff, and that car there had a 9-inch rear end, and we put a full Mark Williams solid diff in the back, no like full spool. So pretty much it was locked. So we thought that was the best thing to do. So we have maximum traction. We can leave the line without wheel spinning and all that. Well, that didn't work too good because something has to spin. And because it didn't do any of that, we kept on breaking transfer cases. Now, the early model transfer cases, a lot of people may not know, they are tiny. They break pretty easy. There's not much of a ring and pinion there. And we struggled with that for nearly a year because the clutch didn't slip. The front wheels couldn't turn faster than the rear or vice versa because everything was just locked up. So the poor little transfer case used to cop it all the time. Like within 2 passes, it's broken.
Sounds about right.
So what we did then, first thing we did was we pulled the gearbox back out and we put just a LSD in the front so it's not fully locked, and that saved the transfer case. I reckon it gave it another 80% of life. And then the next thing we did, we started controlling boost via gear because at the end of the day, it didn't need 30 pound to leave the line. It's not going to go anywhere anyway. So we started leaving the line roughly around 15 to 16 pound. And back then we never had a slider clutch. It was just a lock-up clutch from the word go. we used to load up the drivetrain via a line locker kit, and then just gradually take your leg off the clutch and accelerate. And the best 60 foot we ran back then was, I think, 1.52, 1.53.
Okay.
Wasn't like great, but it was enough to make us run that 8.7 with the power that we had, so it was pretty good.
Yeah, I mean, 8.7 with the power you had, I mean, in comparison, we got down to a best of an 8.2, but we were more like 1100 at the wheels, and we're, I think, 182 mile an hour. So the mile an hour wasn't massively up there. We struggled, obviously, with exactly the same things. I didn't go the 9-inch solid rear end. We stuck with the Evo independent rear end, which I think probably, if anything, hurt us. Particularly, you couldn't buy quality aftermarket axles for the rear of that. So we were running custom axles that instead of braking in 3 passes, we'd get sort of 20 passes out of them. And then the transfer case, same deal. We were replacing those probably every 8 to 10 passes. But as you say, something has to give, and I think what turned the corner for us was, we've got this triple plate clutch to handle the torque that the engine makes, but of course then when you drop the clutch, it's just going to instantly lock and grab, and I personally struggled to mechanically slip the clutch with my left leg repeatedly and consistently off the line. So I think we kind of went down the path that a lot of four-wheel drive drag racers went down at that time. It was kind of the worst kept secret, which was the clutch slipper, sort of little hydraulic unit that basically limited how quickly the clutch would release and kind of mechanically forced it to slip. And that's kind of what, as I say, turned the corner for us. But you are smarter than me. You just did it all with your left leg.
Yeah, no, it was hard. Look, I wasn't as consistent as I'd like to be, but I actually tried the tilt and clutch slipper back then with a smaller pill to slow the pedal down. Definitely works, but back then we never had we didn't have the boost via gear, and because it was a stroker and that, we were struggling because it come on boost too quick and it made a lot of torque down low. I wanted the control of my leg and just have that feel. If I could change back time, I'd definitely set the clutch slider much better, like with the pill or the Magnus, slipper clutch. Definitely the way to go. There's no ifs or buts about that now. Like, it has to be done. So yeah, I know. For any four-wheel drive car. So
I think there's technology has marched on as well, and we're speaking to another guest, Lucas English, talking about some other products that now are available, because the problem I had with the unit we were running, it just literally hydraulically limited how quickly the clutch would release, which worked well to slip the clutch, but the problem was that kind of started from the moment you sidestep the clutch, and depending where you were in terms of the clutch take-up, that made it very hard to actually cut a good light. So your reaction time usually sucked, but the ET and mile an hour were normally pretty good. And back then, and I don't think much has changed, maybe in import drag racing terms, most of us were kind of racing for ETs and PBs, and if you beat the guy in the other lane or the girl in the other lane, that was kind of all well and good, but maybe not necessarily what we're aiming for.
Yeah.
And not really what drag racing should be about, but it was an interesting time back then, trying to beat world records.
Yeah, that was our drive too, like trying to get a record. Our reaction, we didn't really worry about it as much, concentrated on that pass. Trying to ET and PB was always on our mind, and that was our goal, just a PB. And if we won the event, definitely was a bonus.
Yep.
But when back then when we used to race our four-wheel drive cars, if you were trying to cut a light, you're never going to run a good ET because just couldn't get it right.
That's my experience as well. All right, so why did you end up sort of quitting with development of that car? What was the final straw, I guess?
To be honest with you, I was just tired of fixing the drivetrain. I couldn't. We nearly ran out of transfer cases in Sydney, that's for sure. The wrecker that I used to buy him off, he goes, "Don't tell me you broke another one." I said, "Mate, I've broken 3 of them on the weekend." And it was just getting painful. Like, the engine was all good, everything was perfect, the rear end was great. Just that transfer case, we're having a lot of dramas, but we did fix it towards the end. Never told many people about it. I had a friend of mine that used to own a company that used to do modifications in that, and we actually modified a transfer case. We machined the output shaft off it. We splined the pinion gear, the pinion, and we put splines in it. And we turned it into a power glide output shaft.
Okay.
And we machined the housing. Then, it still had factory gears in it, factory housings, everything, but around the output shaft of a 2-speed power glide.
So it was never the crown wheel and pinion in those transfer cases that actually failed, was it? It was just that small spline on the output shaft of it.
Correct. They always used to break and get stuck in the tail shaft, couldn't get them back out. They used to twist that much. So as soon as we went to that was perfect. Never broke again.
You never shared that little secret with me. Till
Yeah,
now.
that was my favourite. So,
too little, too late now.
yeah. Oh, they've got better stuff out now. I see the boys in America from Booston. They all got the 300M shafts, and that was the game changer for the early model Mitsubishis. That was the weakest link.
Yep.
Couldn't put any power in them. So.
All right, well, let's move on from that, and sticking with the 4G63 platform, you're also pretty well known for your red Evo 8. We actually did a tech tour on this, which is on our YouTube channel. We'll see if we can maybe drop a link into the show notes if people want to learn a little bit more about that. But we stumbled upon that car at World Time Attack, where it's been racing pretty consistently in the roll racing events, the Flying 500, I think that they call it.
Yep.
Can you give us a bit of a rundown on what that car consists of and why that was built?
Okay, well, originally we built an Evo 9 for one of our customers, and the first time we built that car, we wanted to try and be the first Evo, late model Evo 789 to run a 9-second pass. And there was a couple of workshops. Everyone was going at it pretty hard. Every Wednesday night, everyone was at the drags racing, which was nice, good competition. And we ended up running a 9-second pass in a full street Evo. And then the next step was, no one had run a 9 yet, so we wanted to go to the next step again, try and be the first Evo to run an 8-second pass. And this was back in 2010. So we got stuck into that car. And again, within 3 or 4 months, we end up running at 8.8 in that car at 165 mile an hour. Pretty much full street time, just a little bit, took some weight out of it in the doors and that to try and get there. But we stopped there, then we took that to the Flying 500. We won the Flying 500 in that white Evo. And then we stopped for about a year, and then that's when the red Evo come along. I said, there's a bit of competition happening, so we got the red Evo, started building it. And it is what it is today. Ended up with a billet block and all that sort of stuff.
All right, so let's dive into that. So that's an Evo 8 from my recollection, isn't it?
That's correct,
okay.
Yes.
So let's talk about the billet block. And actually, let's take one step back. And for a start, what you learnt on that early Evo 1 to 3 chassis versus what you found with that later model chassis. Where were the real challenges in comparison to the early chassis?
Look, the early chassis, I reckon, definitely the rear end on them. For whatever reason, they squat, they work, they take off without much work, like development in them. The later model Evos are definitely very hard to get off the line, but at the same time, you're also carrying a lot of extra weight on the car. So there's a big difference between an early model Lancer 123 or GSR compared to an Evo 8.9. There's at least 350, 400 kilos heavier.
Yeah, and that makes a big difference.
Massive difference. The geometry on the rear of an Evo 123, completely standard. We can get them to squat, pretty much drag the exhaust 100 meters down the track, and they just hook up and go. And never had a problem with them. Where late model Evo, there's a lot of work in suspension to make it squat and go. So it's another challenge on its own. Regardless of how much power you're making, it's just trying to get it to leave the line.
I mean, the engines between the early and the late, obviously they swapped them around from east-west to west-east, or however you want to call it. Yeah. But I mean, predominantly the engines are still very much the same thing, aren't they? It's
correct.
The chassis that was really the big difference. I know in my own experience as well. Yeah, the weight was a massive challenge. But the drivetrain also is completely different. And would you say that the later model drivetrain was fundamentally stronger, or did it have its own set of issues?
Look, the later model one is definitely it is stronger, but we never really, it's hard to say, like they are strong. Like we've got a lot of Evos running around with, 600-700 kilowatts on the street, and they're still running factory diff, factory transfer case just with a wave track in it, and they've lived a long time, like definitely they're very strong. You couldn't run that with a factory 123. They'd break the transfer case straight away. So definitely strong. Everything's twice the size or even triple the size as in diff and transfer. The Crown and Pinion is massive, like completely different. So, but also it has to be that big because, like we said earlier, there's over 400 kilos difference in weight.
Okay, so with this Evo 8, you went down the path of the billet block, and again, we kind of touched on this back when we were both drag racing. The early Evos, the billet blocks, I don't think back then even existed, or maybe right at the end they were just starting to come out with a few people running them. Now we're sort of seeing them pretty much everywhere across all of the platforms. What point with the 4G63 do you kind of feel that the billet block makes sense, or is the only real way to go?
Okay, it's a tricky question. Look, the factory block, definitely we've had them up to 1,000 horsepower. Really, they've been good, but the main problem you're going to be worried about is when you start lifting the head, pushing water. That's the main problem that everyone's having.
Yep.
So the more you push, the more cylinder pressures you got. Every workshop, every person that does them, always, they're just thinking, is it going to make it this hit? Is it going to, how long is it going to last? Can't last forever, that's for sure. That's where the billet block, the way they've designed them, the deck thickness, where the studs are pulling down from, they've, moved the thread, down the ball, like down the block more to clamp the head down. The deck is much thicker. The block is more solid, more rigid, like it doesn't flex around as much. So that's where the billet block comes along and makes a massive difference in sealing compression. And obviously now they're running all the dry decks. We made them dry deck. We tried that and it definitely works. Heaps of success by sealing the compression, weld the cylinder head up, and still running it on the street by running water externally in the engine. And that's made the biggest difference in the world, to run 70 pound on the street all day and not have, coolant, spreading out everywhere and, putting compression in the radiator and that. So
I know with a lot of the high-end drag builds with billet blocks, there is no water jacket at all. Obviously not suitable for a street application, but that gives the advantage of a lot more rigidity in the block material, and the same with bespoke drag components for cylinder heads for maybe some of the V8s. Again, no water jacket is provided, so a lot more rigidity. You've just mentioned their dry deck setup, so where essentially you've got no water transfer between the block and the cylinder head, but you are still running water, so that's an external link between the block and the cylinder head to get that water flow. And
yes.
Where's the advantage in that? If you've still got the water in there, but you've just got the dry deck surface, where's the advantage there in terms of the head gasket integrity?
Okay, the advantages you have there, so if the head does lift a little bit, obviously, it's always going to lift no matter whether it's dry deck or not. You're not going to put water underneath your tyres and, put compression in the radiator, because there is no holes for the water to go through. So all the gasket's doing is sealing your oil and your compression. If you lost a little bit of compression out the side, it's not going to hurt anyone. You wouldn't even know about it, and you can still make the power, and definitely more reliable and safer if you are going to run, over 60, 70 pound on the street, and you want the reliability of it.
Okay. Yeah, that's what I wanted to just focus on. So it's not actually fixing head gasket integrity issues. What it's doing is basically meaning that if you do have the head lift a little bit, traditionally as soon as the head lifts, the first path of that combustion gas is going to escape and go straight into the water jacket, thereby putting pressure into the cooling system, as you mentioned, and the byproduct of that is it can end up lifting the radiator cap, blowing water out into your reservoir. Depending where that is, you then get water under the tyres, which is probably the upshot safety issue that people wouldn't necessarily connect with a head gasket failure. So that's the implications of this dry deck not actually fixing the issue.
100%. Like, that's all you're doing. Lifting the head up. There's obviously so much different studs you can buy, sizes, clamping it down. Pretty much like having a billet block. is going to fix a lot of your head gasket issues, not only because it's dry deck, it's because it's a more of a solid deck. There's no flex, nothing. So it does help, definitely helps. But if it lifts, well, it's going to be much safer than having a block that's got water through it. And it definitely will put compression in the radiator. And if it's a drag car or even a street car with that much sort of boost, water, depending on where your reservoir is, I've seen it happen that many times, water going underneath the tyres, and it's not a good result, that's for sure.
No, definitely not. All right, so the other aspect here is obviously the head gasket material or head gasket design, and here there's numerous different designs, MLS gaskets with stainless wire O-rings, sealing rings, copper gaskets, the list goes on. And I mean, if we look at what the upper echelons of drag racing, the likes of Top Fuel and Top Alcohol are doing, they run a copper gasket with a stainless wire in the cylinder head and then a receiver groove, which sort of deforms that gasket down into the receiver groove in the block. What technique have you sort of found is the most effective and what works the best?
Okay, well, along the years we've tried everything. We've tried, your all different brands of normal multi-layer head gaskets. Yes, they are good, and we've had dramas with some, and then we've moved away from that. Then we went to like just a normal, like you said, wire in the block with a receiver groove and a copper head gasket. And obviously we used to try different things, like have them hanging out 8th thou out of the block, 10th thou, 12th thou, trying to fix the problem. We always made it better and better, but then we pushed the envelope further and then it starts leaking again. Then we started double O-ring head and block on top of each other, so if it tried to lift, there's still a bit of crush on that gasket. Made it better, but still didn't fix the problem because we snuck another 100 horsepower in. And then we moved on again. So the latest technology we've been using since 2009 is we started making fire rings and copper head gaskets, which all we do is put a groove in the block, make a ring to suit whatever thickness that you need, whether it's 40 thou, 60 thou, 80 thou, whatever suits your recommendations or application. And that's been the biggest success, even though you're still running water through the block. That's what we found is the only chance of surviving and making the best power and getting the best sealant out of your engine with that setup, like a fire ring and a copper head gasket.
And when people use that term fire ring, I think everyone's also got maybe a slightly different definition of what a fire ring is. And I've seen these with spikes machined onto the top surface to physically dig into the head. And then, as you mentioned there, like maybe a step on the underside that locates in a groove on the block. So it's physically locked into the block, can't move, and then those spikes actually dig into the cylinder head. But that's not what you're talking about here. You've got a flat surface on essentially the surface of that ring that seals against the head.
Yes, correct. No, there's no spikes, nothing, just full flat ring. We have that hanging out of the block 2 thou or 3 thou, depending on how much boost and application, thicker than the head gasket, so there's more crush on the head. Mm-hmm. You can't go too much, because if you do, it distorts the cam tunnel and you end up leaking oil everywhere from the sides because you can't seal it because there's not enough crush on the gasket. So yeah, no, it's just straight. Everything's got to be machined perfect. The groove in the block's got to be perfect, so the ring actually locates in the block nice and tight, not just moving around everywhere, because if the head lifts and you haven't got those settings right, your compression can still go under that ring, under the groove and out the other side. So that's very important. The machinist has got to get it perfect. Obviously use the right sealant to seal the gasket for water and oil, and the rings do the sealing for the compression.
So I think that's the other part that is easy to overlook. Those copper gaskets, they do a reasonable job when they're combined with a O-ring to actually seal combustion. That's not what you're doing in this case. You're just using that gasket essentially as a packer, but that copper gasket does a horrible job of sealing oil and water, doesn't it? So you need something else to help it do its job there, and that's the sealant.
That's correct. That's right. The sealant's very important. You get a lot of guys using white sealant, Loctite, this, that. The only sealant that will work is that 3-bond, that 1207B. It's like you can't even lift the head off. Sometimes you need an engine hoist to pull the head back off with no studs on it. So it's the only sealant that we recommend, and that does the job, and you get no oil leaks, nothing. So it's been perfect for us. It's worked great.
Okay, well, dropping the trade secrets here, left, right, and centre.
Yeah.
All right, so now talking about fuel as well, you mentioned with that earlier generation car, you ran that on methanol, as did we, and that's kind of been the fuel of choice for most of those running really high boost levels. I'm quite interested to talk to you about the fuel on your Evo 8, because back when we saw that at World Time Attack, that was running on E85, and you've since swapped to methanol. So I'm interested to first of all know why you decided to make that change from E85 to methanol.
Okay, well, we've been running E85 forever in that car, and we pushed the car just from like pump, like when I say E85, from the servo down the road, no drummed E85, no spikes in it, nothing, just full on from the Bowser from United. And the best power we got out of that was almost 1300 horsepower. And I said to myself, like, I am pushing the envelope. I want, it was on 68 pounds, 67 pounds, 70 pounds. It's a lot of boost for, just pump fuel out of a servo. I just wanted to make that little bit more power and have the reliability. So then I upgraded to VP C85. We dynoed the car with that. Unbelievable results, made a lot of power, worked well, but very expensive. It was like close to $859 for 200 litres. So to run that on the street is crazy. And then we stepped it up to methanol, because we've got a lot of experience with methanol tuning other cars, race cars with it, at the same sort of boost level as our street car. And I haven't looked back. It just keeps the engine nice and cool, safer on the engine. The fuel system's there for it. So I haven't looked back ever since I've gone to methanol to make the extra power. So at the moment we're sitting on, I can't remember exactly how much, but it's making over 1460 horsepower or something.
I think you sent me a dyno picture of 1479 if memory serves correct.
Yeah, so
it's not mucking around, is it? Let's just jump back to the E85. So from your pump E85, and I mean, you're pushing 70 PSI back then, which I think most people would sort of say, you're getting borderline for what could ever be safely recommended on E85. But where was the power gain when you went to the C85? So this VP race E85. Yeah, what gave you the extra power there?
Okay, well, with that fuel, we were able to run that little bit more timing in it. And to be honest, we were able to lean it out a little bit better because the fuel had so much more octane in it. And it picked up, I think, with the same boost with the old setup, over 80 horsepower at the wheels, which is a lot of power.
It's huge.
It's unbelievable. Like, I go, wow, that's a lot of power. But also, at the same time, we've run out of turbo, and we had to change everything to get that extra power. So I think the best power we made with the C85 was just on 1300 or 1310 horsepower. Okay. With the old setup that used to run 1220, 1240 with just normal pump E85.
Yep. Now, I'm interested. You said you're only able to use a bit more timing and lean it out a little bit more. So, were you actually running it on the knock limit on the pump E85, or did you just sort of get to a point? And this is no offense, because this is kind of where I got to with my car. I never really found the knock threshold, if that existed. You'd sort of give it a couple of degrees more timing and it would make a bunch more power, and you sort of looked at the power and then you looked at the engine and it was still together, and you sort of thought, well, you know what, let's just maybe go to the track because this is just getting ridiculous. Was that your sort of philosophy? Because, I mean, at that sort of power level, if you suffer from knock, probably don't need knock detection equipment because the engine's going to let you know because it'll be in pieces on the workshop floor, correct?
You're not wrong there, man. 100%. I didn't push it to the limit, but the numbers were there, like the timing wise. I said to myself, can it take any more timing? We threw another 2 degrees at it, see what happens. It did pick up more power, and then I wasn't like, shouldn't I put another degree or 2 in it? Looking at EGTs, everything looks fantastic. Like, very happy with everything. Read the spark plugs. Check the timing, make sure everything was right. Look, the plugs read well, because I've got this thing that I do with tuning cars. Even though I look at all my electronics and data that I see, I always love to pull the spark plugs out after every 2-3 runs on the dyno and actually read the spark plug to see where the timing's at. Mm-hmm. To me, that's very, very important, because you just want to make sure what you're doing is 100% and the plugs don't lie.
Yep.
The mixtures are there. and you see the timing on the electrode where it is, then you know where you're at. And you can actually see cylinder by cylinder where the timing's at and what needs more and what doesn't need more cylinder.
Yeah.
So that's very, very important. But timing-wise, like you said, you can put a bit more. Sometimes it responds and it was happy, but there was a point where I put an extra 2 degrees and it didn't really make much difference. So we took it straight back out and another degree out again, just to be that extra safe.
Yeah.
And then you just go from there. But it's definitely, the timing was where it had to be because it lived for a long time. The engine, it lived for over 3-4 years, no problem. So the timing we knew was where it had to be. And that was it with the 85.
My philosophy when I was dynoing something that's that sort of on edge and making that much specific power as well was my dyno philosophy was always actually quite conservative, which might sound a little strange, but you do a single pull on the dyno, which might be 8 or 10 seconds, and it's only making power for maybe a third of that run length, or maybe half it at the most. And that's not really replicating what the load and the temperatures and the pressures are going to be inside that combustion chamber, inside the engine, in the deep end of the track where it's pulling super high RPM and you've been leaning on it for the whole length of the run. So I think the dyno's useful. Yes, it helps us get the tune dialed in, but I was always of the philosophy is let's get the tune close. And then, we normally have more power than we could put to the track, give or take anyway. So then we would fine tune and optimize it at the track, depending on the conditions that the track was giving us on the day.
Yeah, no, you're not wrong there, 100%. It is just a tuning tool to get it as close as possible as, like for your mixtures in there. So you don't go out to the track in the dark and trying to guess it over there. Sometimes you definitely do have to pull timing out and add fuel to the car to get the mixtures right. Because once you go through all those gears, top gear on a lot of cars, it feels like it's forever. And there's a lot of load on the engine and the intake temperature of going down that track, depending on how you got your intakes up in front of the turbo. It definitely can change a lot of things compared to what you've done on the dyno. So when you go back to your logs, they might not be the same as what they were on the dyno. And obviously we need to adjust to get it right at the track. So
ultimately we don't race these cars on a dyno, so what's happening at the track is what's important. All right, so we've talked about the E85 to C85. Let's talk about this next step to the full methanol. So for those who aren't familiar with methanol, can you give us sort of we don't need a chemical breakdown here, but from a tuner's perspective, where are the advantages with methanol as a fuel?
Look, most of the advantage of methanol is the cooling intake charge. It's as you know, from pump fuel to E85 there was a big difference. Then going from E85 to methanol, it's nearly the same difference again. It's very, very especially on a turbocharged car with that much boost, it can cool those combustion chambers down heaps, like a lot. There's a lot of them, but also it needs the fuel like almost double, like E85 again. Like you need another 40 to 50, even 60% more fuel than E85, even if you're making the same power. So you need, your fuel system's got to be up there, injector size and fuel pump, and but the advantage, most of the advantage are from is cooling, and you can push that boundary a bit more when it comes. Not only timing, it doesn't mean you can throw a bunch of degrees at it. That has nothing to do with it. Like if the engine's happy at whatever 18 degrees, it doesn't mean you can go put 24 in it because you've got methanol now. It's mainly the cooling, and just the methanol makes more power in general.
Yeah, I think there's a couple of things that's probably worth understanding there. We talk about pump fuel to E85, and generally you're going to be chucking around about 38 to 40% more fuel, and if you look at the stoichiometric fuel ratio, 14.7 to 1 for pump fuel, 9.8 to 1 for E85, and then you go to methanol, you're down at 6.4 to 1, but we run them so rich on methanol as well. It's not like a pump fuel or E85 where you've got this sort of rich cliff where you sort of go past a certain point and the power just falls over. On methanol, I kind of find you almost are limited by the ability of the ignition system to light off the fuel air charge. But other than that, the power doesn't really kind of get hurt so much by being rich, which of course is safe. And the more fuel you can pour in as well, the more you've got that cooling effect, which you've already talked about, which why we see a lot of turbocharged and supercharged drag engines on methanol choose to eliminate the intercooler, which I'm interested, did you go down that path with the Evo?
Yeah, definitely. Like you said, the richer you run them, they don't really drop that much power. It's not real good for the oil, but definitely it doesn't drop that much in power. But while you're tuning it, every engine is different, whether it's intercooled, not intercooled. When it's not intercooled, obviously you have to run them on the richer side so you don't hurt the engine because you're relying on that for cooling. But we notice a lot too, when you go lean on methanol, you can make a lot more power, but it's very dangerous. You've got to know the engine, where it's at, what it's happy with.
There's a very sharp edge there where it's making good power, and then all of a sudden you got a bunch of melted parts and you're starting again.
There's not much of a window. Not much of a window when it comes to methanol. The window is very small. It's either yes or no, where E85 is forgiving.
Let's wrap up on the Evo, because there's still one more topic I want to cover. But before we move on, so we talked about power. I don't think you've run it at the drag strip yet with that new power level, but what's the current PB down the drag strip?
With the old setup, the PB was 8.9 at 171 mile per hour.
Okay.
In full street trim, like full exhaust, radial tyres, electric windows, full standard car, factory car.
So literally drive it through the Macca's drive-through on the way home from the strip.
No problem at all.
Okay. All right, so let's move on to your other passion, which is the SR20, and we've already sort of joked about the fact that it's unusual to have a tuner who's really got two engines that they feel equally sort of in love with, but that's where we're at. And you've got this S15. This is a full tube chassis car from memory.
Yeah, three-quarter chassis.
Three-quarter chassis, okay.
Yeah.
And that's gone pretty deep into the sixes from my recollection. Can you give us a PB on that?
Yeah, that's gone 649 at nearly 219 mile per hour.
Okay, so it's not messing around.
No, definitely not.
Yeah. The thing with the SR20, and I don't want to maybe get offside with a whole bunch of Nissan fans out there, but from my experience tuning, dozens, if not hundreds of these over the years, and everything from circuit cars to rally cars to street cars, was the SR20 DET itself. I was never a big fan of. I always felt that for the same turbo combination and the same boost level, give me a 4G63 and I'm going to make more power every day of the week. Plus then you've got problems with reliability around the valve train on the SR20 DE and DET because of the big, ugly, heavy rocker. However, when they brought out the VE cylinder head on the P11 and P12 Primera, this was a game changer, wasn't it? Can you talk us through what that head actually means for the SR20?
Yeah, well, the SR20 DET, everyone's, they've got a bad name when it comes to rockers, all the drift cars, like you said. What puts them out for the rest of the day is broken rockers, and sometimes they can drop a valve and cause a lot of damage just from a simple breaking a rocker. When those P11, P12 heads come out, definitely a game changer. No more rocker problems because they're pretty much shaft mounted. They're not sitting on a lifter.
So they can't escape now.
Can't go anywhere. It's locked in, ready to rock and roll. It doesn't matter what you throw at it, whether it's a two-step, valve bounce, mate, that rocker ain't going anywhere. It's ready, it's solid. So it's more, and the head also makes more power. The ports are better, flow better. Honestly, it's an unbelievable head for an upgrade for an SR20. You couldn't ask for anything more.
Yeah, I agree. And we were running the same combination in our endurance race cars, so I've seen this firsthand. I mean, the other thing with the VE cylinder head is they kind of copied Honda's VTEC mechanism. So we've got 3 lobes per cylinder with kind of a high-low cam switchover point. I'm interested with a drag application where I'm going to guess that you're really only interested in the engine performance over, maybe I'm only guessing here, maybe 8 to 10,000, 8 to 11,000 RPM or thereabouts. Do you eliminate that VTEC switchover point?
Yes, we definitely do. We just use the outer lobes. We get rid of the middle lobe because it's not really beneficial for what we do. We leave the line at 50, 60 pound anyway. So it doesn't really make a difference for us. So we get rid of it, we machine it all out, make our own spaces, get rid of a lot of weight in the rocker side of things, because we actually rev our drag SR20 to almost 12,000 now,
Okay.
like 11,800. So the less weight we can have up there, the better for us.
Definitely. All right, so the other aspect, and we unfortunately found this out the hard way as well with the VE cylinder headers, they run a shim between the tip of the valve and the rocker, and that sets the valve lash. It's a mechanical system, not hydraulic like the factory Evos. And you do need to be a little bit mindful of these, because it is possible to have a shim actually pop out, particularly depending on the type of limiting you're using. Whereas with a drag application, the two-step that you mentioned before, critical to get the car off the line, what are you doing to get around that with the factory shim system? Are you eliminating that completely?
Yeah, what we do, we've had custom valves made by Supertech.
Mm-hmm.
We run shimless, so there's no more shims. They don't exist anymore. It's a must on a two-step, especially when you're running that much sort of boost. There is a chance the shim can pop out. So we've set them up shimless, and best application you can actually do for reliability and just constant reliability, I suppose. Never had a problem ever since.
So basically that custom valve from Supertech is longer, and you're setting the valve lash by essentially tipping the valve, so the clearance is then set between the tip of the valve and the rocker instead of the tip of the shim in the rocker, correct?
That's correct.
So is there any downside in terms of that? Because, I mean, we don't have visual aids here, unfortunately, to show our listeners, but the diameter of the factory shim, I don't have the numbers in front of me, but let's say it might be 8 or 10 millimeters at a guess, and then we're looking at the tip of the valve, and the valve diameter, again, I don't know that off the top of my head, let's say it's 5.5 or 6 millimeters perhaps.
Yeah.
So you're whatever the specific number is, you're reducing the diameter that's contacting that rocker. Is there a reliability deficit from that? Are you creating more wear on those components because you've got that concentrated over a smaller area?
No, you don't, because if you look at the rocker, it's just pushing on the middle of the valve, and it doesn't really do any damage or change reliability or anything like that. We modify the retainer, so there's no step in it for the shim to sit in. So you do have to modify the retainer so the valve's fully exposed, instead of being like on a factory SR20 retainer to accept the shim. You can't just leave the factory retainer in there, because then the rocker will foul on the retainer trying to push the valve down. So you've got the longer tip on the valve, you run a different retainer, more of a flat base retainer, and very reliable, and never really had a problem at all.
Okay. Now, there's about a million things I could dive into on this car as well, but we are probably going a little bit long here. But there is one other area I did want to talk to you about with it, which is the clutch. So a little bit outside of the tuning side of things and the engine building side of things. But we've already talked about with the four-wheel drive stuff how hard it was to get these cars off the line. And what we see with most V8 professional built rear wheel drive tube frame drag cars, they run what's called a slider clutch, often referred to as a slipper clutch, which is quite a special, quite a unique piece of equipment where you can actually basically tune the slip and the clutch depending on the base pressure and centrifugal weight that you put on it. Can you just give us a quick rundown on sort of how that actually works and why that's so important?
Okay, on the Drag S15, we run a Ram triple 7-inch clutch, slider clutch. Like you said, you can adjust the base, the centrifugal weight on the clutch, and there's that much adjustments on that clutch. It's very temperamental. You do need a lot of experience. It looks easy, or looks hard at the same time, but once you understand it, you say you can make the car do whatever you want to do as long as the driver shifts on point. Because if you set up that clutch to just to quickly say you want to rev it to 11,000, you need lock up between 10 to 11, and you for whatever reason short shift it, all your adjustments are gone out of for that run. It's going to slip and not recover. Like it might recover, but you've definitely lost your increments that you've done for that clutch on getting down that pass. It'll still get down there. It'll sound like it was okay, but when you go back and look at your logs, you'll see the separation between the input shaft and the ratios and the rear drive shafts. And if you don't have all those meeting properly in the slip between gears and lockup, that's how you know if the clutch is correct or not adjusted right. And you can also adjust the base pressure and how much you need off the line, because all those adjustments have a point in that run, what they're doing, like base, weight, what RPM you want it to lock up at, how much slip do you need between gear changes to get rid of the shock off the tyres in between gear changes. So everything has to be perfect.
So one of the problems with a manual, I'm just going to take a step back here. One of the problems with a manual transmission is that we've got this change in RPM instantaneously on a gear shift. Obviously, we shift at 12,000 RPM, and depending on our gear ratios, we might drop from 12,000 RPM down to maybe 10,800 in the next gear, or whatever that may be. So the tyre's hooked up on the track and has to physically drag the engine RPM back down, and what that does is provides a shock loading, and that can really upset a powerful car and makes it prone to break into wheel spin on the shift. At best, it unsettles the car, whereas we look at an automatic, they tend to absorb a little bit of that because we've got a little bit of slip between the engine and the converter, and that doesn't tend to be as harsh on those shift. So that slipper clutch, you're talking about the centrifugal weights, and again, without some visual aids, it's a bit difficult, but essentially these are weights that you can put onto little arms on the clutch, and it's that centrifugal force. Essentially, the more weight you put on it, as the RPM increases, the clutch will tend to lock up more. So that's what you're talking about there. You can make the clutch lock solid at a certain RPM, but then it can be basically designed so that on the shift it actually loosens up a little bit and allows a little bit of slip of the clutch to soften those shifts. So, in a 2-second rundown, is that sort of a fairly sort of reasonable way of explaining it?
Yeah, 100%. Like, obviously, when you go look at your log after that run, you can see where it's locked up, and if you needed to lock up earlier in between the gear changes, you would have to add some more centrifugal weight, and you just got to look at how much slip you have got in top gear, because honestly, you'd want it to pretty much be fully locked up in top gear to run your ET. The best of ETs a mile per hour, and we've seen that. We've been caught out before where we raced Jamboree back in 2012. We had our first run, the weather wasn't looking good, so we had our first run. We went 7.7 at 178 or 180 mile an hour, and we left the car what it was, and all night I'm tinkering away thinking, what should I do with this clutch, because the power, we know that it makes the power, so we all night we're just contemplating, we should do this, should do that. So I borrowed some intermediate plates from someone which were DLC coated I've never used before. We put them in there first thing in the morning, got up early in the morning, started putting it together, readjusted the clutch, set up the base, and believe it or not, that was our first 6-second pass and gained the world record of SR20 just by setting up a clutch, and we had the same power, just getting it right.
Yeah, I think that's what I've seen from my limited exposure to them is they can really make or break an entire run. And they do require that knowledge around the setup, but it's not only that, it's then how to adjust that setup to cope with the changing track conditions, which we'll get during the course of an event as the track rubbers up or the VHT's laid down, or even the UV changes. That's going to change the amount of grip that's available. So you do end up walking a bit of a tightrope. They're also quite high on maintenance as well, which is why we see these sorts of cars. Basically, between every round, the gearbox gets removed and the clutch also gets removed to have the clutch plate sometimes machined down, or at least everything reset. So you're basically back at the starting point, correct?
That's correct. Like, depending on the run, what we normally do after every run, check the logs, and then we just check how much, after we've zeroed the clutch after the first run, you put your dial gauge in, and it will tell you exactly how much you've lost off the clutch plates, whether it's 5 thou, 10 thou. If it was a good run, you always lose around, between 3 to 6 thou. You're on the money, which is good. Normally just reset your base again, like you'll zero the clutch and set up your two-step. But if it's had a bad run where, you've short shifted it and it's used 25 thou, well, you're in a bit of trouble. You might have to pull the box back out and reset everything, clean the clutch plates up, and go again. Reset everything and start from scratch. So we've been down that road.
They become a little bit less maintenance when you're actually in that window and you've got it all working nicely.
Definitely right. Like if it's all working good, we've had the box in there for 3-4 passes, not a problem. Where if it's all out, you could be pulling it out every pass so to get it right. So we've been down that road as well.
Worth it when you all get it working. Look, Mick, I think we'll move on here because we have taken up a fair bit of your time, and as I say, I could probably spend another hour talking about the S15, but it's great to get that perspective on it. Just before we leave it though, can you just give us an idea of what the peak power numbers on that are and how much boost you're running to achieve that?
Okay, lately we've just, I don't know if you guys have seen it, we've done a new setup on it. Put a new cylinder head, same turbocharger. We're up to 1770 at the hubs.
Wow.
And it still had another 1800 RPM to go. And it was still climbing, so God knows where it was going. I think it was going to close to maybe 1900 horsepower at the hubs.
Go for the moon.
Yeah, we just got a bit scared, to be honest with you. There was nothing wrong with it. It was so loud and the ground was shaking, and we just said stop. We just couldn't believe the line, how far it was going. And that was on nearly 88 pound of boost.
When's it going to the track next?
Very soon, to be honest. We're just trying to find a private test day to go and test it. The sooner the better, to try and push that limit a bit more, so if we can go into the 6.3s or 6.2s if we can. In a 3/4 car would be great.
Absolutely. I look forward to see how that pans out. All right, we've got a few questions that we like to ask all of our guests at the end, and the first of those is what's sort of next up for you in your future? Where do you sort of see Micks Motorsport heading?
Oh, look, that's a tough one, that one. Look, we're just trying to concentrate on what we do, bring out some more nice cars like Evos and Nissans and that, build a lot of nice cars for customers so they can enjoy what we've been practicing and working on, and share our experience that we've spent in the last 25-30 years on building motor cars for people, so they can enjoy their pride and joy as well. So that's the game we're trying to do. So
more of the same. Nothing wrong with that. If it's not broken, don't fix it.
That's it.
Okay. Next question. If you were to sort of go back in time and be able to give some advice to a younger version of yourself, maybe to fast track your progress through the industry, is there anything you could sort of say? What would you do?
If you love what you do, mechanic, I'd be working hard, hanging around with people with knowledge, learn, and what can I say, man? Just if you love drag racing, never give up. Don't ever give up. Nothing comes easy. So, knowledge, we all learnt the hard way, mate. We've broken a lot of things in our life, so for us to say we've never broken nothing, that'll be the biggest lie, I think. And that's how you learn. So by breaking things.
Yeah, I don't think it's possible to get to the pointy end in any drag class without breaking a few components, unfortunately. And I don't know, for me, it's one of those sports that the highs are incredibly high, but unfortunately it comes with lows that are also incredibly low. But it's a sickness, and once that bug's bitten, it's hard to get away from it.
You're not wrong there. Like breaking things, honestly, it teaches you more and more about becoming better at what you do. You understand everything, with the limits for everything, and it definitely gives you an experience by breaking things.
I think in that vein as well, you quickly learn that drag racing is not just about making the most power possible, and it's about the entire package and getting that power to the ground in a way that you'll get the car from A to B and not, hopefully, break too many things along the way.
Definitely not wrong there.
All right, last question for today, Mick. If people want to follow you and see what you're up to, where are you at on social media? How should they reach out?
Okay, we're mainly on Facebook, Micks Motorsport on Facebook, and we do have Instagram as well. But most of our stuff is always shared on Instagram and Facebook.
Perfect. All right, look, thanks for your time today, Mick. It's been great to chat, and again, look forward to hearing what the S15 does when it hits the track again.
Thank you very much, Andre, for your time as well. Thank you very much.
Cheers. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.